Hello, Algebra 2 friends. This is Mrs. Levenseller again. Hope you're getting the most out of your remote days here. So we're just going to use this video time to refresh your brains on multiplying polynomials. And then there's the online Schoology practice for you to try afterwards. Same deal, you get 3 attempts at all the questions. And you want to do it until you get as many correct as you can. So you don't have to use all 3 attempts if you get them right on the first try. But let's take a look. So multiplying polynomials here, I just want to start with some quick vocab. And polynomials is a general term for an algebraic equation that has multiple parts, so multiple terms, and each term is something that's separated by addition or subtraction. So for example, 3x squared plus 5x minus 6. Each one of these pieces is considered a term because it's separated with addition and subtraction. So a monomial, if you look at the prefix mono, that means 1. That's something that has one term, like maybe just 3x to the second. A binomial is something that has 2 terms. The prefix bi means 2. So maybe 3x squared plus 5x. A trinomial, just like a tricycle, something that has 3 terms. And so that would be something like 3x squared plus 5x minus 6. And a polynomial is something that has many terms. So you usually use that to describe something that has 4 or more terms, but also a monomial, a binomial, and a trinomial all fall under the category of polynomials. So the general term is polynomial, but if we want to get more specific, monomial, binomial, and trinomial are 3 words we can use to do that. All right. So the first thing that we're going to look at is multiplying a monomial, so something with 1 term, times a binomial, something with 2 terms. Oops, 2. So it's going to look like distribution, and that's really all we're doing, just like you looked at last class. And just remember, anytime you're multiplying variables, your exponents should increase on that variable. So we're starting with 5x squared times 2x, and that's like 2x to the first. So I multiply the whole numbers, which I get 10. And then x squared times x to the first is x to the third. Then I go to the next term. 5x squared times negative 3 is negative 15x squared. So I want to look at my answer and say, can I combine any like terms? Well, 10x cubed, negative 15x squared, those are not like terms. So that means this is my final answer. Next, let's look at one that has multiple variables in it. So here we have 3x squared y to the third times 2x plus 6x to the fourth y to the ninth. This is still a monomial because all of those things are connected with multiplication, not addition or subtraction. And this is a binomial because they're separated with one addition side. There's 2 components. So same process, I'm going to distribute, and we're going to multiply the like terms together, the like components together. So 3 times 2 would give me 6x squared times x to the first, we just saw, gives me x to the third. And then y to the third, well, there's no other y here, so I'm just going to bring that down as part of that first term. So 6x cubed y to the third is the first term. Now I'm going to take 3x squared y cubed and multiply it by 6x to the fourth y to the ninth. So again, 3 times 6, that would give me 18. X squared times x to the fourth. I'm adding my exponents when I multiply, so I get x to the sixth. And y cubed times y to the ninth, adding my exponents would give me y to the 12th. Again, these aren't like terms, so that is my final answer. All right. Let's see, I don't know what happened here, but next we're going to look at multiplying a binomial times a binomial, which sometimes people refer to as FOIL and sometimes people refer to as double distribution. Okay, so let's take a look at this. Still distributing, so this time we're distributing 2x to both parts of the x plus 1 and -5 to both parts of the x plus 1. So it's why we call it double distribution, because we're distributing two different things. So the first, I'm going to do 2x times x, which gives me 2x squared. And then 2x times 1 is positive 2x. Then we're going to go take the -5 and distribute. -5 times x is -5x. -5 times -1 is -5. And if you look at this here, this is also the same thing as FOIL. What we did first, so first were the first two terms, 2x and x, that's the f. Then we did the outsides, 2x and 1. Then we did the insides, -5 and x. And then we did the last, -5 and 1. So whether you use the acronym FOIL or you just think about it as distributing both terms of the first binomial to both terms of the second binomial, you're going to come up with the same answer, hopefully. And then once you get here, is there anything that we can combine? Well, 2x and -5x, those are like terms. So my simplified answer would be 2x squared minus 3x minus 5. All right. So that's an example of double distribution or foiling. The fourth example that I have here is still going to be a double distribution, but we have to remember what this is really saying. So remember, if I gave you something like just x squared, we know that that's really x times x. So if I have 3x minus 4 squared, that's really 3x minus 4 times 3x minus 4. All right, so this power here tells me to write it twice. And then once we write it twice, now it looks just like this problem up above. So we're going to double distribute here. Let me get a different color. So first term, 3x needs to get multiplied by 3x, and I get 9x squared. 3x then times the -4 is -12x. Then I'm going to go to the second term here. -4 gets multiplied by 3x, and I get another -12x. And -4 times -4 gives me a positive 16. Again, I can combine like terms in the middle, so 9x squared stands alone, but -12x and -12x can be -24x plus 16. This is also referred to as a perfect square trinomial, because if you look at, well, first of all, if you look at this this polynomial here, there are 3 terms, and so that makes it a trinomial. The first term, 9x squared, is a perfect square. It's 3x times 3x. That makes it a perfect square. 16 is also a perfect square because it's 4 times 4. So it's called the perfect square trinomial because the first and the last terms are perfect squares. And there's a little shortcut we can do to multiply that out, but as we get better at it, we'll look at that. All right, I have one last example for you today, so thanks for bearing with me. I don't know what happened here. I had this all organized. There we go. So here we have a binomial multiplied by a trinomial. Again, still double distribution. So -2a to the 5th is going to get multiplied by all 3 terms of the trinomial. So I'm going to start with -2a to the 5th times 3a to the 3rd is -6a to the 8th. And then -2a to the 5th times -4a squared is positive 8a to the 7th. And -2a to the 5th times 6a, -12a to the 6th. All right. So I took that first term and I multiplied it by all three pieces of the trinomial. And now I'm going to do it with the second term. So a squared times 3a cubed is going to be plus 3a to the fifth. A squared times negative 4a squared is negative 4a to the fourth. And a squared times 6a is positive 6a to the third. Now when I look at all the different exponents, this is 8, 7, 6, 5, 4, 3. None of them are the same, which means I can't combine any of these. So this is my full answer. If there were some exponents that were the same, then you would be able to combine like terms wherever you saw the same power. So go ahead and give the practice questions to try on Schoology and email me or Zoom me if you have questions.